In this question, a saturated solution of barium carbonate, BaCO3, is initially at equilibrium at 20 degrees C. We're given the equation for this dissolution reaction. We've got barium carbonate solid in the reactants, and we've got barium 2 plus ions and carbonate ions, both aqueous in solution in the products. We're also given KSP, which is the solubility product constant. In other words, the equilibrium constant for dissolving. We're then told the system is stressed by adding some barium chloride, BaCl2, a soluble salt, which increases the concentrations of Ba2 plus and Cl minus in the solution. So we initially have a solution of barium carbonate. So we've got Ba2 plus and CO3 2 minus. Then we're going to add barium chloride. So we're adding Ba2 plus and we're adding Cl minus. So the first question asks, what is the common ion in this situation? The common ion is the ion that's in the solution and that we're adding to the solution. So we have barium 2 plus in the solution, and we're adding some more barium 2 plus to the solution when we add the barium chloride. So the common ion here is going to be Ba2 plus. Next, we're asked what needs to change to counteract this stress. So we're talking about Le Chatelier's principle. Le Chatelier's principle tells us that if we have a system that's initially equilibrium, and then we put a stress on that system, the position of the equilibrium will shift to counteract that stress. So what that means is, if we have something initially equilibrium, as we do here, we have this solution of barium carbonate. We then put a stress on that system by adding barium chloride. The equilibrium position is then going to shift to counteract the adding of the barium chloride. So we've already decided barium is our common ion here. So if we look at our equation here, we're increasing the concentration of barium 2 plus by adding some barium chloride. So what needs to change to counteract that stress? Le Chatelier's principle says we're going to want to do the opposite. So if we've added barium 2 plus, we need to decrease the concentration of barium 2 plus in order to counteract the stress. So here we need Ba2 plus to decrease. Which direction of the reaction should be favored to make this happen? Well, if we need to decrease Ba2 plus, we need the reaction to shift towards the reactants in the left direction, so that we're going to have some of our barium 2 plus and our carbonate ions combining together to form barium carbonate solid. That's going to decrease our barium 2 plus concentration. So we need to favor the backwards reaction because it consumes Ba2 plus. In which direction would the equilibrium shift? We already said it's going to shift towards the backwards direction. That's towards the reactants. Now, if our equilibrium shifts towards the reactants, that means we're going to get more of our solid made and less of our ions. So how is the solubility of barium carbonate affected by the addition of barium chloride? Well, we know that our equilibrium position is shifting towards the solid, which would mean it's becoming less soluble. So the solubility of BaCO3 decreases. So in this example, we can see when we add a common ion, because that increases the concentration of that ion in the solution, the equilibrium positions are going to shift to the left towards the reactants so that we'll consume some of that ion and produce more of the solid, which will decrease the solubility of the salt.